Hi, welcome to the video tutorial for lesson 29. It's the penultimate lesson in the Thinking Maths pack. And I call it Describing and Talking the Line. And the last time I did this was was a revision class with the year 11 group. And what it highlighted was, one, how lazy they were. Two, they've never actually made sense of what lines are, mathematical lines. And the penny had never dropped about what y equals 4 means, what y equals x means. And so I think this is one that really needs to be done in year 8, because they will learn the rules, but have they internalised what it actually means and how we make sense of space and how we visualise lines and where that can be applied. So in this lesson there are 3 activities. There's a starter that's very interactive, and then there's 2 periods of drawing lines. The second episode is drawing a vertical and horizontal line describing them. The third episode, I apologise, is describing multiple lines, and then there's a possible extension where they've got to apply it to a real life situation. So the start is getting them to try and reinvent the need for the 4 quadrants that we often have on a graph. So the pupils have to draw this. They have to draw 5 points and place them on a piece of paper based on my instructions. So the scenario I give in the cartoon you could use is someone's climbed up a tree, and when I first did this, the children knew that a couple of the teachers and I had been to Peru, and because I was the youngest, I said there was one point where we got lost and I had to climb up a tree and shout down instructions. So I tell it as if I'm in the rainforest and giving instructions. You could do it lots of other ways. I've done a scuba diving course with my daughter where it really makes you think about where things are in space. As part of one of the courses, you have to do a kind of rescue and recovery session in the sea, and you've got to try and remember things where things are and try and work out space. So what you do is you constantly go round in a bigger and bigger square. So you would flip twice, flip 3 times, flip 4 times, flip 5 times using your fins. And so it's really interesting to get the children to think about space and how we divide up space. So I will say to them, and what is also good is it's laterally inverted. My left is their right. They've got to think lateral inversion. And I really like that, because in my training at university I did lots of dissections. That's right, that's left. So when I look at someone, I think right and left. I don't think mirror image. So it's really interesting to think, how do we perceive space? And some people who have very good spatial perception actually could be very good mathematicians. So I would start by saying, I'm going to describe 5 points in the rainforest, and I want you to draw them with a mark A, B, C, D, E. And I'll say the first one is right over there in the distance, and the next one is just along from it, B. And so on, and I make stuff up, and I say, there's a flower there, there's a tree there, just in flower, oh, there's a monkey in front of it, and that's where the camp is, right over there. So the pupils then have to compare theirs with mine, and some of them are spot on. And then the question is, how could we turn this into a map? And what I like about doing this with a bit of paper and making it real, some of them say, well, it depends what they say, but essentially they'll talk about dividing it up, so I just do that. You can divide it vertically, you can divide it horizontally. So what you end up with is the 4 quadrants with the origin in the middle. And the children will realise that. And it's funny, because often they'll say, oh yeah, look, that's the middle, that's the origin, that's 0, 0. So you say, well, okay, what do you think the coordinates of A are? What's B? What's E? What's D? What's C? What would this be? So that's how you could do the start. The length depends upon your pupils and how much you want to make of it. I just like to go to town with these and really like to engage the children in the challenge and the novelty of it, so it's very, very different. The second part of the lesson involves the children drawing on this grid. And the language is important here, because we're playing on the difference between a segment of a line and a line. And the children think a segment of a line is a line. Mathematically, the line is an infinite extension in either direction. So you say to them, draw points 2, 1 and 5, 1 and draw the line, and then mark 2 other points on the same line. Draw the line that they lie on. So they would do, I'm going to go along 2, and at 1, I'm going to go along 5, and at 1, and they might do that or that. And what they'll do is they'll draw that as the line that they lie on. Some children won't. Some will do the whole thing, but that's quite rare if you just do it in this way. Some of them will draw the whole line. And you say to them, okay, what I want you to do now is describe that line so someone else can draw it. And this is where it's worth letting them talk. It's not about the right answer, it's how do they describe the line so someone else can draw it. And often what you'll get is you'll get an essay to describe that line. It starts here, it ends here, it's straight and da-da-da-da-da-da-da-da. Others do slightly less, others do more. What you're hoping for is that. That often doesn't happen. But suddenly they'll go, oh, it just gans through 1, as the children I used to teach today. It gans through 1, of course it's y equals 1. The second part is to draw this line, which goes into the negative value, which is x is 4. So you're moving away from it's a horizontal line that goes from here to here and this, and it goes through all these points to just say, that's y equals 1, that's x equals 4. And for many children, the penny drops. They've never made sense of it in that way. So that's the second part of the lesson. The third part is I like to view this as Kaplunk, where the pupils draw all of these lines, different gradients, but same intercept, different intercept but same gradient, and describe them and say what they notice. What do they notice about lines and what's similar and what's... I'm not going to draw them because I'm not neat enough. But you get the sense that you're really making them think about the nature of lines and what they look like and how the shape and their position helps us describe them. You could end this by saying a line goes through 0, 3. Draw it and get your partner or get another group to write the equation of the line. There is an extension, and I'll just read it out, where you say, okay, someone, it's hard because I think in here it says a president. You couldn't do that because you could then talk about the president of Syria wanting to shoot down Donald Trump's missiles. But the idea is someone wants to develop a missile system that will shoot down any rocket. A rocket is fired on a trajectory y equals half x plus 1. Right, that's a trajectory. If a missile launcher is placed at y equals 3 or y equals 7, what trajectory, what equation of the line of the trajectory of those missiles would they take if they wanted to knock that missile down that was following that trajectory? That's the possible extension asked them to do. You're using equations of something that's happening in space, missiles, and how this is really, for a lot of children, this lesson, because it is the lesson 29, it's the last lesson, it really does make them think and visualise lines in space. As I said, for me it's like Kaplunk. Very, very powerful experience. Again, that one could be a homework or become something you could do later.